So yesterday when I started the notes, I said that the second day of notes would be more about circular combinations, and number one, that can't even have it, it's circular permutations. And then number two, that's actually not what this day is about at all anyways. So I was a little off, but we'll figure it out. But after there is a day two, because a lot of times people struggle with day one because they're trying to do what we're going to do today the whole time. They're trying to figure out probability on the first day instead of just counting how many possibilities are there. Not what's the probability of it happen, how many ways can it happen. So now today we're going to use some of the same ideas, but now we're going to find out a probability, or how many ways could we get what we want. Okay, instead of just how many ways could I arrange things or combine things. So a word consists of one M, four I's, four S's, and two P's. All right. If the letters are randomly arranged in some order, what is the probability that the arrangement spells the word Mississippi? Right? We're just saying it's a word, right? So are there lots of possibilities of jumbling up those letters? Well, what is the problem seeing they are typed? The S's all look the same, correct? So if I were to switch any two of the S's right now, would you really figure that as a different arrangement than the one you saw before? No, so we have to first find out how many distinguishable ways can I jumble them up. So the same thing, we have a problem with the I's and with the P's. Right? So let's first just figure out, well, how many ways can I kind of jumble that up? And if you remember from the other day, what we do is we take the total, like basically, I think they call it n factorial, and then they did like a1 factorial and 2 factorial and all that stuff. These were all your repeats down here. Okay, so n factorial on the top is basically saying, well, let's figure out how many things we're looking at. Well, how many letters are we looking at? Well, we've got 1, 4, 4, and 2. What does that add to? 11. So just jumbling up those letters just in general is 11 factorial, correct? So now what we're going to do is we're going to say, okay, great, I can jumble them up, but some of them I can't tell the difference that I jumbled them. It looks like the exact same arrangement, even if I jumble them up again. And so the M's, well, those don't really repeat, do they? There's nothing up there. But the I's, how many of them are there? Well, there's 4 of them. So down here we're going to put 4 factorial so that I don't count that in there. And then we're also going to do for another 4 factorial. What are we going to do that for? The S's, very good. And then is that all the repeats, or do we have more? Okay, we've got to do what? 2 factorial, very good, and that's for the P's. Okay? Again, we don't really have to worry about the M's. Okay? So again, you could do this by hand if you wanted to, or we all have the calculators handy. We could cancel off things or whatever we wanted to do. But let's make sure that we have our calculators working properly. Because if you are going to type this in all the way, you probably do want to put parentheses around that bottom so it divides all of it. Okay, instead of just typing it straight in, it might start multiplying on you. And you don't really want it to do that. So let's make sure all of us can calculate these properly. And in a second or so here, we'll see what people are getting. Anybody feel they have the correct answer? Yes. 34,650 is correct. Now, would you agree that's basically what we kind of talked about yesterday, right? That's how many ways I can just arrange that in general, correct? So now we're talking probability, which remember is kind of successes, number of ways of being successful in getting what you want, over the number of ways it can happen total, correct? So what does that represent? That's total, right? So if we're talking a probability here, that's just the total number of ways I can do that. How many distinguishable ways can I actually put them in the right order? Distinguishable, only one. It's right there. Mississippi, just like that. Because again, if I switch the S's, yeah, I can't tell the difference. But what if I switch an I and an S? Well, yeah, you're going to tell the difference, and it's not going to spell Mississippi. Okay? That'd be interesting to try and pronounce that if we actually switch the... Yeah, that would be really weird if you tried that. But really, there's only one way to arrange them the way that I want it to happen. Okay, so this is being successful, and that's arranging them that way, distinguishable. This is the distinguishable ways of just jumbling up the letters in general. Okay? And it's not very good. Yeah, like something like 0.02% or something like that. So you probably wouldn't have thought it was that low. Okay? But if you think about it, just switching the M and the I, and it's not what we wanted. So there's lots of ways to put it up here so that it's not what I want. Correct? and very few to get what I want. So is it possible? Yes. Probable? No. Okay. Were there any questions on that first one? Okay. Determine the probability of being dealt 5 diamonds from a standard deck of playing cards. In other words, you were just dealt a poker hand known as a flush, which is a pretty strong hand in most cases. So what we want to do is find the probability. So we need the number of ways I can successfully get what I want over the total number of ways you can just do it in general. Well, what are we talking about? Total number of ways I can do what? Get 5 cards, right? Well, how can we figure that out? So we're doing successes on getting what I want over total, which really is probability, right? And so let's do total first. I think it's probably the best way to go. So I want to know how many ways can I get 5 cards. Do you believe there's quite a few ways you could be dealt 5 cards? And there's a lot of ways, right? Okay, and these are a lot of the probabilities that a lot of those guys in Texas Hold'em, or the women in Texas Hold'em, they know a lot of these probabilities in their head. They just have them memorized, okay, as to how this can work. And so what you're going to do, and not necessarily this one, because it's not necessarily 5 cards. Well, do you think that's a permutation or a combination when we're talking about a poker hand? Why is it a combination? Yeah, because can't you jumble them up in your hand and get them in the order you want them once you get them? If you get a straight flush, you don't have to get them in that order to have a straight flush, right? Or a straight, you don't have to get them in that order for it to count, all right? And so it is a combination. I am choosing 5, that's a pretty good seat. I am choosing 5 cards. Oh yeah, I followed up a really good seat with a bad 5, yeah. How many cards are there to choose from? 52. So that's how many ways I could be dealt 5 cards. Let's figure that out. Might be a surprisingly large number for you. The question was, we're going to have the formulas memorized, meaning the combination and permutation? No, you can use your calculator for those. Or do you mean the successes over total, or? You mean the general ones like n factorial over n minus r and all that stuff? No, you don't have to have those memorized. Okay, what do we got for our bottom? Yeah. 2,598,960. So what does that number represent? 52 C5, or it's 52 NCR 5. There's a button. Well, you just have to find the NCR button. If you don't have that button, you're going to have to know the formulas then and do it by hand. Or really could just do 52 times 51 times 50. You know, you can do it that way too, via the blanks. Okay. So yeah, that's again something we need to find, because that's very helpful, is to know where those are in your calculator. Okay, so that's, again, basically the number of ways you can be dealt a 5-card hand. Well, if you don't have that button, your 2 options are to know that formula and do it by hand, or to get a calculator that does have it. Those are your 2 options. Yes, all the school calculators will all have that, the ones that are at least in this room. Yep. Okay. And then, well, we haven't found out what probability yet, though. That's just the total number of ways you can be dealt 5 cards. So now I would like to get 5 diamonds. Does it matter what order you get those diamonds in? So is this a combination or permutation? Combination. It doesn't matter what order they come to me in, right? So I'm going to choose 5 cards again, but out of how many? How do you know 13? There's 13 diamonds, exactly. There's 13 of each suit. Yep. So 13, choose 5. Obviously, going to be a significantly smaller number than the 2 million, and 2.5 million almost. Probably surprisingly smaller. What's that? 1,287. Probably surprisingly lower, correct? So of those 2,598,960 hands, only 1,287 of them will result in a flush. Basically of any kind, really. Right? Because I just said 13, choose 5. I didn't say they had to be diamonds, right? So is it a very good chance or a very good probability to get a flush? That's why it's one of the stronger hands. But you have to realize in some cases I could pick another hand that's a very weak hand that you have the same probability of getting. Right? It's just we've decided that that's a stronger hand. Okay. What is the percent on that? Does anybody figure that out? 0.05%, right? So it's very important to realize it's 0.05%, not 0.05 as a decimal, right? So that is really close to the probability on the first one, though, isn't it? Relatively close to the same thing. When probably starting the problem, you didn't think they would be anywhere near each other as far as probability. Yes. The question is, can we do royal flush? If we have time, I can work through that with you. Do you think the percentage will be higher or lower? Yeah, much lower, right? Because we're adding in there that it has to be particular cards, right? It's a little trickier, but I can run you through it maybe a little bit later. Yeah, we'll work it. This is the one where if people get the first two, they're feeling pretty good about themselves, and then they kind of run into this one. They're like, uh-oh. So a jury consists of 5 men and 7 women. So I'm saying I know that's what the jury has. And what I would like to do is I would like to take 3 people out of that bunch. And I want to know, and I'm going to randomly take them out of there. Like juror number 1, juror number 5, right? We don't know gender by that, right? And so then we're going to calculate the probability that when I select 3 people out of there, that all 3 of them are men. Would you suggest this will be highly probable or a very low probability? Or middle of the road probability? Yeah, it's not probably going to be all that probable. Okay? So what do we have to do? And one of the things I like to do first, whenever doing these problems, if it is successes over total, is I like to figure out total first. Okay. So what am I trying to do? Total, what do I mean by total? It's basically how many ways I can just pick 3 people out of there, right? Because I'm picking 3 people out no matter what. So let's find out how many ways can I pick 3 people. There's probably quite a few. Now, does it say on here that I care what order those people come out in? So combination or permutation? Combination. So for our total, we are choosing 3 people in all, correct? Out of how many? Nope. 12, right? So again, this is just how many ways I can get 3 people out of there. $220. That's how many ways I can pick 3 people out of that bunch. So not very many because we're starting with such a lower, like last time it was 52 cards, right? Well here, now we're only got 12 to choose from. So that first number actually does change this quite a bit. So now what I have to do is figure out, well, and this is kind of the trickier part, how many ways can I get 3 men? So here's how I look at it. I want to get 3 men and no women, correct? So what I should do is figure out how to do each of those separately, and I said the word and, right? And multiply them, correct? Because that's what the word and means. So let's find out how many ways, well, can I actually do that? Well, how many men are in there then? So this will be the men here, and then I'll put the female over here. So men, well, how many are there? 5, and I would like to choose 3 of them, right? Would that tell me how many ways I can choose 3 men? And I would like to choose 7, choose 0. The reason I'm showing you this way, because we could probably do this without doing the 7, choose 0, but what if all of a sudden I ask you for 2 men and 1 woman or something like that, then you'd be able to do those problems just by changing this up a little bit, right? Because do you notice, though, that on the bottom, overall, I have choose 3, correct? And then the top, overall, I have choose 3, right? So those better match. Don't be choosing 4 on top and 3 on the bottom. That's not going to work out too well for you, right? So 5, choose 3 is 10. 7, choose none. How many ways basically can I choose none of them? Yeah, 1, by not choosing any of them, right? So we see that 5, choose 3 turned into 10, and 7, choose 0 turned into 1. Okay. So in other words, 1 out of 22, which isn't great. It's not terrible. It's way better than the other ones we've had. I think as percentage-wise, it's 4.5% or something like that, right? We have a question. Yeah. Exactly. The question was, what if it was that thing that I said earlier, 2 men and 1 woman? It would be 5 choose 2, 7 choose 1. But you notice again, it is still choose 3 on the bottom overall and choose 3 on top. You see that? How it does end up being a total of the same. Okay. And I would suggest that that example right there that I just kind of wrote in black, would that be a higher probability or lower? Yeah, that would be much higher, correct? Okay. We would have a much better chance of that happening. Okay. Very good. Any questions on what you've seen today? We'll do a royal flush at another time. Not right now, no.